A very good morning to all the participants. A warm welcome to all of you are present here. Welcome to this fourth day of the 1 week online FDP on harnessing virtual labs for effective student engagement. Till now, we've had many team members from NITK Surathal who had been giving us demonstrations on various disciplines. Yesterday, we had Mrs. Vismaya and Mrs. Shrestha ma'am who are handling the sessions on circuit engineering and physical sciences. And today we are going into the core engineering disciplines and chemical sciences. And for that, we have from the same team, along with Shrestha ma'am, we have Dr. Vaishali ma'am, and also we have Ashika Pai ma'am. So both of them are from Virtual Labs team at NITK Surathkal, outreach team of Center for System Design, NITK Surathkal. So without wasting much time, I would like to hand over the session to the team. Shrestha ma'am, over to you.
Thank you, sir. Hope my voice is clear and audible.
Yes, sir. Yes, ma'am. Yes.
Yeah, thank you, sir. Yeah, so very good morning to one and all present here. So welcome back for today's session on virtual labs that are specifically with the demonstrations of virtual labs in 4 domain areas. So today we'll have demonstrations from different labs which are common to both mechanical, civil and allied branches, and also fifth experiments that are common to chemical sciences or chemical engineering as well. So along with me, we have Dr. Vaishali and Ashika from Virtual Labs team at NITK Surathkal. So they'll be handling with the demonstrations for today. And to summarize the points on virtual labs, what it is, just a summary. As we discussed in the previous days, virtual labs are nothing but computer-based labs, as we all know now. So it's an initiative from the Ministry of Education. The main features are anytime, anywhere lab, also free to access, and requirement is just a computing device with internet connection. And structure, if you remember, it is very similar to lab manual. Okay, so along with aim, theory, procedure, set of questions, reference links, feedback link for each and every experiment, you will be able to find in Virtual Labs platform. And it is a website. In Google, if you just search Virtual Labs, the first link will take you to the website, national website of Virtual Labs, from where you can access different labs and experiments. So I hope you all remember these things that we discussed in previous days. This was just a summary of what we discussed earlier. So I just went on quickly. So keeping these things in mind, we'll now start with the demonstrations. So I'll stop video and I'll stop talking from my end, and I'll hand over the session to Vaishali ma'am, who will be taking you with a few of the labs and the civil engineering. So thank you, ma'am. Over to you.
Good morning to all. I'm Dr. Vaishali, working as project manager in CSD department. Hope my voice is audible.
Yes, ma'am.
So I think you got the idea now what is a virtual lab. Actually, virtual lab is an innovative online platform designed to simulate real-world lab environments, allowing users to conduct experiments and practical activities through a computer interface. With the VLab users can manipulate variables, observes results in real time, and gain hands-on hands-on experience from anywhere in the world. So today we'll see one of the core subject of the engineering branch, that is some of the experiment from civil engineering. So these are the broad areas of the civil engineering labs. I think already some of the labs are in your syllabus. And these labs are developed by various institutes like IIT Delhi, NIT Kesuratkal, IIT Hyderabad, etc. So today we'll see some of the experiment from Environmental Engineering Lab 1, because this lab is important, because most of the experiments are related to determine the water quality parameters. Now everywhere you will go, the main problem is water criteria, the quality about the water, everywhere it is going on. So let us see how we can determine water quality parameters in the lab. So first is introduction, objective, and a list of experiment. These are total 7 experiments are there in environmental engineering 1. Actually, it is divided into environmental engineering 1 and environmental engineering 2. And target audience. So this lab is useful UG, PG as well as diploma students who are doing diploma in civil engineering. And course alignment, these are the syllabi of this lab aligns to the following universities in India. After that, feedback. So this, after using this, you can suggest or you can give your suggestion so that we can improve the lab, or any addition is required that we can do it. Here, if you click this link, you can share your experience. So let us see, or we conduct, shall we do one of the, or conduct one of the experiment from this environmental engineering 1. So today we'll see how to determine the hardness of water, or hardness in water. So because nowadays the water quality parameter is everywhere discussing, and one of the main important parameter is hardness. Most of the people telling our water is very hard, we can't use it, like that. So let us see. So first aim, in every experiment, the first part is to explain the aim or objective of the experiment. Here it is to determine the amount of total hardness present in a given water sample by EDTA titration method. So this experiment is done with the special name, that is EDTA titration method. Theory explains what is the hardness, and usually there are 2 types of hardness. One is permanent hardness and temporary hardness. Usually temporary hardness we can remove by boiling of the water, whereas permanent hardness we can remove for the other methods are required. So these are the reactions involved during this titration method. So EDTA, what is the name of EDTA? Why here we are using this erichrome black tea as an indicator, and for this particular experiment. And for this, we used this IS code for this particular experiment. Theory explains about the hardness, types of hardness, and reactions involved during the experiment, etc. Next, pretest. Based on based on theory, there are some multiple choice questions are there. Students have to answer this. After that, they have to submit here. So their score also appear here, and answer will appear in green color, and wrong answer appear in a red color. Next one, procedure. These procedure steps will be followed on the simulator. How to arrange the experiment, what solutions we are using, everything is explained in this procedure part, and calculation part, how to do the tabular column, etc. Next one, simulation part. So simulation is same as how we are doing the experiment in the lab. So first is objective or aim. Here it is to determine the amount of total hardness present in a given water sample by EDTA titration method, and apparatus used, pipettes, conical flask, burette, beaker, dropper, etc. Solution used, ethyl diamine tetraacetic acid, which is known as EDTA solution, water sample, calcium carbonate solution, ammonia buffer solution, erythrome black tea as indicator. So description is about the hardness of water. Hardness is defined as a measure of ability of water to cause precipitation of insoluble calcium and magnesium, salt of higher fatty acids from soap solutions. And there are two types of hardness. One is temporary hardness and permanent hardness. What is temporary hardness? If the presence of bicarbonates of calcium and magnesium, then it is known as temporary hardness. Permanent hardness is nothing but the presence of sulfates, chlorides, and nitrates of calcium and magnesium. So this is the setup of the uh, instruments. So these are the instruments which are used for this particular experiment. First, we have to do standardization of EDTA solution. In any experiment, first the standardization of the solution is important. So first, how we will see how to do the standardization of EDTA solution. So first, we have to take EDTA solution in the burette using funnel. Pour the EDTA solution to the burette up to the 0 mark. Close the bottle, and the solution level is up to 0, up to 0 level, but the measurement is at lower meniscus. And one more important thing is you have to remove the funnel. Sometimes students will forget to take this funnel and they will do titration like that only. So first you should give the instruction that the funnel should be removed from the burette. Next, we have to add 10 ml of 0.0 m calcium, that is molecular calcium carbonate solution to a conical flask through graduated pipette. So click this button to fill the solution in the burette, in this pipette. To release the solution, you have to click down arrow button. Next, we have to add ammonia buffer solution to remove the interference of the particle. Ammonia buffer solution is 1 ml to the conical flask. Meanwhile, there are few questions like Viva questions will appear during this experiment. So in this experiment, why ammonia buffer solution is added to the sample? So it is to remove the interference, also to maintain the constant pH also. Next, we have to add 3 to 4 drops of erythrome black tea indicator. After adding the indicator, solution color turns to brick red or wine red. Now titrate this solution again is EDTA solution. So before starting the titration, note down the initial reading. It is always 0. To start the titrate, open this knob so that solution runs to the conical flask. Titration, when the color changes to blue, we have to stop the titration by closing this knob. And note down the final burette reading. After that, make the tabular column like this and enter all the observed values. Now we have to find out CaCO3 equivalent to 1 ml of EDTA is how much. Formula is volume of CaCO3 divided by volume of EDTA. So it is nothing but 1 milligram of CaCO3. So 1 degree of Clark is equal to 1 part of CaCO3 per dash parts of water. So it is 70,000 parts of water. Particularly I did wrong because to know the substitution and for the calculation purpose. After that, standardization of the EDT solution. Next one, sample titration. So fill the burette, same procedure. We have to take the EDT solution in the burette. Now we have to take 100 ml of water sample to the conical flask through graduated pipette. In the during the standardization, we have to we had taken CaCO3 solution in the conical flask, but after the standardization, we are doing the sample titration. So we have to take 100 ml of sample in the conical flask. To fill the solution, this pipette, we have to click this button. And to release this, we have to click this down arrow button. So hardness that cannot be removed by boiling is called permanent hardness. Next, add 1 ml ammonia buffer solution by automatic pipette to the conical flask. After that, we have to add indicator, erythrome black tea, 3 to 4 drops. After adding the indicator, solution color turns to wine red or brick red. Now titrate the EDT solution till the color changes to blue. To start this titration, we have to open this knob. Titration should continue till color changes to blue. After that, stop the titration by closing this knob. Note down the final view rate reading. So here, one of the simplest Viva question. Titration is carried out until the sample changes its color from dash to blue, that is wine red or brick red. Now make the tabular column and note down all the observed values. And now we have to find out total hardness by using this formula. A into B into 1000 divided by C, where is what is A, what is B, and what is C, everything is there. So for this sample, we got 53 milligram per liter as CaCO3. CaCO3 is a unit of hardness. So which of the following is not a unit of hardness, that is degree centigrade. So the limit of hardness as per BI standard is 300 milligram per liter. That is true. So for this inference is the limit of the hardness as per BS standard is 300 milligram per liter. The total hardness of given water sample is 53 milligram per liter. So we can use it for, because it is within the safe range and we can use it. After the simulation, again post-test questions are there. These questions are little bit advanced than pre-test questions. So students have to answer, click the right answer, and they have to submit in by using this link. Again, the correct answer will appear in green color and wrong answer will appear in red color. Already I shown. Next one, the references. So there are two links are there. One is simulation demo and experimental demo. So simulation demo is same thing what I had shown in this part, but it has the voice. And experimental demo is same how we can do it. By showing this, the students will understand in the better way. So these are the references and these are the contributors list. Again, the feedback. So after using this, you can share your suggestion or anything so that we can improve this. And similarly, another one of the important lab in civil engineering is transportation engineering lab. So here also it is introduction, objective, list of experiment, target audience. Total 8 experiments are there, and target audience. This lab is again useful to both UG, PG as well as diploma students. And course alignment. These are the universities which are following the same syllabi, and feedback. So you can share your experience by clicking this link. So today from the transportation engineering lab, one of the simplest experiment we can see, that is specific gravity test on bitumen. So aim is to determine the specific gravity of the given sample of bitumen. Theory explains what is the bitumen. Bitumen is nothing but the residue or byproduct obtained by the refining of the crude petroleum. And what is its specific properties? These are the specific properties, and also how to calculate the specific gravity by using this formula. What is W1, what is W2, W3, W4, everything is there. And for this, we had used this Indian Standard Code Book. After explaining the based on the theory, there are again few multiple choice questions are there. The students have to answer this. Next one is procedure. These procedure steps will be followed on the simulator. Next one is simulation. So this is one of the simplest experiment. Objective or aim is to determine the specific gravity of the given sample of bitumen. Apparatus used specific gravity bottle, or this bottle is also known as pycnometer. Weighing balance, distilled water. So description, specific gravity of bitumen is defined by uh, Bureau of Indian Standard as the ratio of the mass of a given volume of the bituminous material to the mass of an equal volume of water, and temperature of both being specified as 27 degrees centigrade. So this is the setup. First, we have to take clean and dried specific gravity bottle is weighed along with stopper, that is W1. Now we have to on the weighing balance and we have to make it 0 by clicking this air button. Now keep the specific gravity bottle on the weighing balance and it shows the weight of the bottle, that is W1. Now this specific gravity bottle is filled with distilled water and it should be placed in water bath maintained at 27 degrees centigrade. Close the stopper. And now we have to keep this bottle in the water bath maintained at temperature of 27 degrees centigrade. After that, we have to again weigh this bottle on the weight balance and tear it to 0. Now it shows the weight of bottle with distilled water, that is W2. Next, the bituminous material is heated to a pouring temperature. So that bituminous become liquid. So we have to pour this liquid bitumen to pycnometer or specific gravity bottle. Now again we have to weigh this bottle with bituminous. The bottle on the weighing balance and it gives the W3 weight of specific gravity bottle with bitumen. Next, the remaining part of this, the space of the bottle should be filled with distilled water. And keep the bottle in the water bath for 30 minutes at a temperature of 27 degrees centigrade. After that, we have to remove from the water bath and again we have to weigh. So weighing specific gravity bottle with bituminous and distilled water, it is W4. Now we have to find out the specific gravity of the bitumen, because everything we know, we have to just substitute the all values in this equation. So since the specific gravity value of bitumen ranges from 0.97 to 1.02, according to BIS, the bitumen is stable for pavement construction. So same based on simulation, post-test questions are there. These are the little advanced than pre-test questions. After that, references, and this is the simulation demo. And these are the references, and these are the contributors list. Feedback, you can share your suggestion after using this lab, or any experiment you can explore, so that after that you can share your suggestion. Similarly, you can explore the experiment from any one of the labs. So these are the main labs of the civil engineering. So you can explore any one of the lab, and you can show it to your students, and after that you can share your suggestion. So this is from my end. Hope it is useful to you. Thank you.
Yes, thank you, ma'am. My name is Ashika. I hope I am audible. Vaishali, ma'am, you can stop sharing your screen. Yes, thank you. Okay, so good morning, everyone. My name is Ashika Pai. So I'm working as a junior research fellow in Center for System Design, and also I'm a core team member in the VLAB development and outreach program. So, taking this session forward, I will be looking into some of the common experiments that come under civil and mechanical domain. So, let me share my screen and let's continue the presentation. I hope my screen is also visible. Um, yes, so now I think all of you know the website's name, how to reach it, and what are the different domain areas. Still, I'll give a brief intro. So here we have a total of 9 broad that have been defined. So today I'll be looking into some of the common experiments of civil and mechanical engineering domain areas. So if I go into civil engineering, so here are the various experiments that have, sorry, various laboratories that have been developed inside the civil engineering domain. Similarly, if you want to look into the mechanical aspect of the experiment, so you can just click on mechanical engineering and you can see the various laboratories that have been developed under mechanical engineering. Okay. So one thing that is here is some of the experiments or some of the laboratories that are common in between mechanical and civil, that is SOM and fluid mechanics, have been developed under the civil engineering domain itself. So first I will look into, we will look into the experiments which are common to both civil and mechanical. And then depending on the time availability, we'll look into the other experiments as well. So now I'll be moving on to the SOM lab. So this is a lab developed by NITK Surat itself. So again, I am pretty sure that all of you are completely well aware of the user interface. So towards the left-hand corner, we will be having our navigation tab through which we can toggle between the different options. So here, the most important part in this is the list of experiments. So here, a total of 14 experiments have been developed under the Strength of Materials lab. So now let's take any one of the experiment and see how the experiment goes on. So for let's take direct shear test on mild steel rod. Okay, so now once I have selected direct shear test on mild steel rod, now all the information that is there in this particular web page is only regarding this particular experiment. Okay. So now here, as already explained, we have the theory portion. So in this theory portion, there will be the basic concepts of what is direct shear test and why is it important, and if there are any, if at all, IS codes that we have to refer. that also have been mentioned. Okay. So next, moving on, we have the procedure. So this procedure tab is nothing but a familiarization tool so that the people who are completely new to this web page will get a pretty good idea of what they will have to perform inside the simulator. So as you move down, you will be shown what are the various steps that you have to do in order to move forward in the simulation. Yes, so next we have self-evaluation and quiz. So both of these are some of the MCQ questions pertaining to the particular experiment in question. So now here all the questions will be related to the direct shear test concept itself. So the students also can answer these questions in order to gain more knowledge and get a idea of their level of understanding of the subject. Okay. So next, here we have our simulation window. Next, we have quiz. Yeah, I've spoken about the quiz and self-evaluation. So next, one more important feature of this VLab is we have something called as experimental demo video and simulation demo video. So these are the videos developed under Lagupata it's an initiative by CST and NIT Suratpur. So here, along with the procedure, so in the procedures tab, you have a pictorial representation of how the simulation is going to look like and how you will have to perform the experiment. But again, in the videos tab, we have two demo videos. So one is the simulation demo video. So in this, you will have a detailed video description of how this particular experiment has to be conducted. And then we also have an experimental demo video. So now, if the student wants to know the practicality of the particular experiment, or they want to look into how you have to actually conduct the experiment in a physical laboratory, then they can look into these demo videos. So let's look into both of these videos so we'll get a better idea. Okay. So if I just click on it, the video will be so here they show each and every step that we have to follow. Okay. So this is the experimental demo video. So next, along with this, we have the direct shear test simulation demo video as well. So let's quickly look into that as well. So now just by looking at this video, we'll get a pretty good idea of what we have to do in the simulation. So after the setup is done, we have to click on the next button and start the experiment. Wait until the specimen fails, note down the failure load, and stop the experiment. So that is for trial 1. Similarly, we'll be having to do 2 more trials for the same experiment. So when you click on the next button, we'll be getting 2 more trials of the same kind. And at the end, after the 3 trials, we'll be having to calculate what are the different double shear strength values. So that is about the complete experiment that we will be doing in the simulator. Okay. So now let's directly move on to the simulation. So once when I click onto the simulation, all the other parameters of the web page gets hidden so that all of the concentration goes on to the conduction of the experiment. So first we will be showing what is the objective and what are the apparatus used. So now, even inside the simulator, we will be having some guidelines which will help us to do the simulation. So now here we have a written guideline which is telling that I have to take the milestone rod specimen and determine the diameter of the specimen using the vernier calipers. So here I can see I have a vernier caliper and they have also provided a rod. That is a specimen, milestone rod specimen. And there is guiding arrows. So this guiding arrow also tells me that I have to click on this particular point. So when I hover over the specimen, you can see that my cursor changes to a hand icon. So that says that this is the correct place that I have to work on. So any other place I click, it is not going to work other than simply clicking on the specimen rod. So now I have found out the diameter of the milestone rod specimen for this particular trial is 6.04 mm. So now after this, I have to move on to the step 2. Okay. So now again in step 2, you can see I have the written guideline which is telling me that I have to place the milestone rod specimen inside the shear attachment and again place it back into the UTM machine. So now how do I do this? So I have to go and click on the shear attachment and the milestone rod specimen will be placed inside the shear attachment, and then again the whole shear attachment setup is placed inside the UTM machine and the machine has been set to its required length. So this is all about the experimental setup. That is the instrument setup that you have to do before starting the experiment. So moving on, here is the third step. So here the machine is switched on and the load is gradually increased until the specimen is fractured or the required load is outed out. So what I have to do is I have to just start the machine and I have to note down the failure load. So at what load does the milestone rod specimen fail? So once after it has failed, I have to stop the machine. So now I have gotten the failure load for trial 1. And here we have the observation table for trial 1. That is, we have found out what is the diameter. Based on that, we can tell what is the area of cross section. After that, we also have what is the failure load. That is what we had noted down. So now, substituting all of these data into the double shear strength formula, that is failure load into acceleration due to gravity divided by 2 times the area. Here, the area is 2 times the area because we are working under double shear. If it was single shear, then area would be A. That is P into 9.81 by A. So moving forward. So now we have to continue the same steps 3 times. So that is, this is trial 2. We have to again place the shear attachment. And now wait for the specimen to fail. Note down the failure load and stop the machine. And this is the trial 2. Similarly, we have trial 3. Okay, so the diameter is 5.94 mm. Next step, place the shear attachment, place the specimen rod inside the shear attachment and again back into the UTM machine. So now, for the last trial, switch on the UTM, put down the failure load and stop the machine. So this is the observation for the third trial. So when I move on to the next step, here is the place where I have to calculate what are the double shear strength values. So first is participants can also calculate it so that it becomes a little bit more engaging. but yeah, even I'll be doing it 1600 into 9.81 divided by 2 times the area. So the first answer comes about 274.02. Okay. So next is 1700 into 9.81 divided by 2 times the area, that is 22 into 28.83. So it's 289.23. And for the last value, it is 1400 into acceleration due to gravity, that is failure load, into acceleration due to gravity divided by 2 times the area, that is 2 into 27.7. So that's 247.91. So let's see if the values that I have calculated are correct or not. Okay. So now we can see there is no percentage of error. So here also the students can understand if they are going wrong in any of the calculation part. So if there is any mistake, then they'll be able to find out what is the percentage of error that I have conducted. And then finally, what is the average double shear strength? So average double shear strength is the average of all the 3 values that have been taken in the experiment. So that is about the simulation part of this particular experiment. So I hope you're able to understand the importance of virtual labs in this situation. So most of the students either at the end of the semester will not be able to completely recollect what is the way to conduct the experiment, or there will be many practical problems for allowing the students to get into laboratories and conduct these experiments. So instead of that, the students can always come onto this platform, look into the experiments and get a better idea and understanding of how this experiment works and what are the various steps that are needed to be done in order to move forward or in order to understand the concept. Okay, moving forward. So similarly, I am not going to go into all the different types of all the experiments that have been developed here, but I request all the participants to please go through all of these experiments and provide their feedback as well. Next, moving on. Another common subject that is in between civil and mechanical is the fluid mechanics lab. So we'll be looking into one of the experiments in fluid mechanics. So again here, so most of the experiments that have been developed under VLab, the user interface will be almost similar in nature. Okay, so here we have the introduction, what is the objective of this lab, and the most important part is the list of the experiments. So in fluid mechanics lab, here 5 experiments have been developed. And then we also have a fluid machinery lab. So if you look into fluid machinery and look into the list of experiments, again, 7 experiments have been developed. So a total of 7 plus 5, that is 12 experiments have come under the fluid mechanics topic. So let's look into any one of the experiments. So if I take calibration of V notch, so again, you can see it's the same interface. On the left hand corner, we have all the navigation bars in which we can toggle through. Also, we have the videos here. So that we have the calibration of V notch, simulation demo, and the experimental demo videos. So now let's dive. Okay. So next in the theory portion, we have all the important information regarding notches, how we can find out the discharge through a V notch. All those things have been mentioned here. So again, in the procedure also, we have the pictorial representation. So now let's conduct the experiment of calibration of the V notch. So here, this is the objective and the apparatus used. So now here also we have the written guidelines telling us what we have to do in the various stages of the experiment. So first we have to start the machine and move on to the next step. So now we have to open the inlet valve and allow the water to fill into the channel till the crest level. So the crest level is nothing but the bottommost point of the V notch. So let's do that and move forward. So now we have to find out what is the total head of water to find out to get what is the theoretical discharge of V notch. So here we have 10.04 minus 3.15 centimeter. So that's 6.89. So let's check if it's correct. Okay. So now we have the theoretical discharge value. What we have to calculate is 8 by 15 root of 2g into tan theta by 2 into h to the power 5 by 2. So here the parameters that we have to substitute is acceleration due to gravity as 981 and theta as 90 degrees. So here, as theta is 90, theta by 2 will be 45 and tan 45 will be equal to 1. H is nothing but the head of water, that is 6.89 to the power 5 by 2. That is 2.5. Okay. And then we have to substitute this value. So for the time being, I'll be adding some arbitrary value and let's check. So the result is 2943.7 centimeter cube per second for the theoretical discharge. So now similarly, we'll be moving forward and now we have to find out what is the actual discharge. So why are we finding this? We are finding theoretical discharge and actual discharge to find out what is the coefficient of discharge for this particular notch. Okay, so we'll be noting down what is the time required to fill 10 centimeter. So here we have area of the tank as 3500 into h is 10 centimeters. So 3500 into 10 divided by what is the time? Time taken is 20. So here it's 1750. Let's check it. That is right. And we'll move forward. So now here, these are the observations. Okay. And now we have to find out what is the coefficient of discharge. So coefficient of discharge is nothing but Q actual, that of Q theoretical. So that is 1750 divided by 2943.7. So the value comes out to be 0.59. Let's check it. And that's right. So this is for trial 1. Again, the same steps has to be followed for trial 2 as well. So we'll be noting down what is the head of water that we are providing. So here, why this is being done is we are giving different openings to the wall so that different volume of water is being discharged so that we get the average value of coefficient of discharge. So again, now we have to find out what is theoretical. Okay, so what is it? H, what we have found out is 4.89. 4.89 to the power 5 by 2, that is 2.5. Okay, into what are the other parameters that we have to do? Into 8 divided by 15 into root of 2 into 981. So let's see if this is right. 24916. Okay. Yeah. So it was rounded off to 1 decimal place. That's okay. And now let's move forward. So now again we'll be calculating what is the actual discharge. So here we have area of the tank 1500 into height of water is 10 divided by the time taken is 44.6. So here 784.75. Let's check it. Yeah, 784.7 is the correct value. So now we have to find out what is the coefficient of discharge. So here it is 784.7 divided by 1249.2. And the value comes out to be 0.628. 6. So that is for trial 2. Similarly, we'll be opening the valve for a different amount of water to get into the experimental setup. So now final reading is 8.04. So that's again 4.89. Let's change. So Q theoretical will be 249.2. And now again, what is the time required to fill it for 10 centimeter height? 6. Okay. So now again we have to find out what is the Q actual by Q theoretical, that is coefficient of discharge 0.62. And check it. Yes. So now we have done for the 3 trials. So now we'll stop. Forward. So now we have this characteristics curve of actual flow rate versus head. And in the graphical solution as well, we are getting a coefficient of discharge of 0.63, which is very much aligning to the values that we had found out earlier. So that's about the calibration of Greenwich experiment. So again, in the references section, you'll be having what are the textbooks or journals that have been referred for the development of this lab and also the contributors list. So now moving forward. So these are the other experiments that are present in the fluid mechanics lab and also in the fluid machinery lab. So you guys can look into the different parameters. So now let's take up another experiment. So in this session, I think even chemical related faculty members are also present. So we'll be taking one of the common experiments that is common to civil and chemical engineering students. Okay. So now let's see how to determine pH. So that is one of the most basic experiments. So again, all of the parameters are the same. There is theory. Okay, something in the older labs was they had something called as self-evaluation and this, but now that has been renamed as pre-test and post-test. Though all of the questions that are the major goal of the pre-test and post-test remains to be the same. So the students can answer these questions and get a better knowledge regarding their subject. So again, in the procedures tab, we have the pictorial representation of what we have to do inside the experiment. And yes, in the older labs, we had a dedicated videos tab which used to tell us what we have to do in the various, what we, the different video links, that is the Lagupata links. But now that has been merged into the references tab itself. So you can see both of the simulation demo as well as the experimental demo links inside the references tab itself. So if you fail to find the demo videos, you can also look into the references tab. So now let's move on to the simulation. Yes. So here we have the objective and the apparatus used, but also now you can see there is a new parameter that is seen, that is called as the description. So now if I hover over description, I have a definition, that is pH is a term used to express the intensity of the acid or alkaline conditions of a solution, and it's a measure of the hydrogen ion activity in the solution. Okay, so in the theory portion, what we had seen, we have a detailed explanation and the basic concepts of what this experiment is about, what does it stand for, and what can we find out from the conduction of the experiment. But in the description tab, we have a very concise form of what this experiment is all about. So here in this experiment, we are going to find out the pH, and here it is telling us what is pH. So it is a measure of hydrogen ion activity in any of the solution that we are considering. So that's about the introductory page. So here you can look into the pH meter, the beaker, and the experimental setup. So now first is we have to select any one of the given sample. So let's select seawater and let's see how the alkalinity test the pH test has to be conducted. So now first, before finding out the pH of the required sample, we have to first calibrate the pH meter. So we have to follow the same procedure for this. So now again, inside the simulation, we have the written guideline as well as our guiding arrows. So now this is telling that I have to clean the temperature and the electrode probe with distilled water and dry it using a tissue paper. So this is my instruction. So I'll be clicking on the distilled water bottle and will be cleaning it. So now it is clean the distilled water. Now we have to dry it with the tissue paper. So now when I give OK, this particular command will be executed. Okay. Okay, so now I think all of you can see a pop-up question has come up on the screen. So these are called as formative questions. So in the newer labs, based on our experience and the feedback that we have gotten, we have added these formative questions. The main idea of inculcating the formative questions is to make the simulation even more interactive with the students, and at the same time, the students will be able to gain much more knowledge regarding the experiment while conducting the experiment itself. So without answering this formative questions, you will not be able to move forward in the simulation. So the pH scale, here I have 4 options. Is it a linear scale, an exponential scale, a logarithmic scale, or none of the above? So if we had looked into the theory portion, we would have gotten the answer to this. So it's a logarithmic scale. Okay, so now it allows me to move forward in the simulation. So moving forward, so now first I have to, the second step in this calibration of pH meter is to dip the electrode and the temperature probe in buffer solution of pH value 7. Okay, so we on the machine and we'll dip our probes. So here what is the basic idea? We are going to give a buffer solution that is equal to or more than 7, and one more will be less than 7. So the another formative question has come up. So I have to answer this in order to move forward. So buffer solutions I use to calibrate pH meters because they resist changes in the pH. So that is true. So now This buffer solution has calibrated the pH meter, and now we can see it showing as 7. So now the calibration is right for the pH buffer solution of pH 7. So now again we have to clean our electrode and the temperature probe. So why is this being done for each and every step? So that is to make sure that there is no discrepancy in the later values that we are going to find out. So now again we have another formative question. So I hope you guys are able to understand that with the inculcation of formative questions, the simulation has become much more interactive with the students. So pH is a measure of hydrogen ions, oxygen ions, hydroxide or carbonate. So it's a measure of hydrogen ion. So with this, we will be moving forward to the next step. So now we'll be placing a buffer solution of pH 4 and dipping our probes. Okay, so now the pH meter has been calibrated. So that is done. So now we have to determine the pH value of the sample. So now again, what we have to do is we have to clean our probes. So after each and every reading, this is the standard procedure that we have to follow. So again, we have another formative question. What is the neutral value of pH scale? That's 7. And then move forward. So now in step 1, we had selected our sample as seawater. So now we will be finding out what is the pH value for this sample. So the pH of seawater has come out to be 8.3. Moving on. So now we have to answer this question that if the pH of seawater is 8.3, is it alkaline, neutral, or acidic? So whatever value is above 7, it's taken as alkaline or also called as basic. So this is the inference that we have to, that we'll be arriving at, that if the pH is less than 7, it's acidic, it's equal to 7, it's neutral, and if it's greater than 7, it's basic or also alkaline in nature. Yes. So that's about the experimental simulation for this particular experiment. Okay. So again, we have another newer lab, that is advanced remote sensing and GIS. Okay. So most of the civil engineering students will not have much exposure to advanced remote sensing and GIS applications. So the students also can look into the various experiments that are provided here and get a very good idea of how these technological advancements are being used and how they can stay up to date. So here we have georeferencing of the topo-shaped cartography of GIS data. We also have digitization. We have photogrammetry, how to conduct photogrammetry survey and RGB data capturing using unmanned aerial vehicle. So unmanned aerial vehicle is nothing but drones. So then we have georeferencing of the aerial maps using DGPS. So DGPS is nothing but differential global positioning system. So that is a high-end positioning instrument where the normal GPS signals are now with are provided with a higher accuracy of 1 to 3 centimeters. Okay, and then another most important technological advancement is the lidar application. So how volume estimation can be done using aerial lidar and precision agriculture using multispectral UAV. So multispectral UAV is nothing but the sensors which are mounted on the drones, which help in finding out our uh, plant health. So that is also been done here. So a total of 10 experiments have been developed So I think all the students will be extremely helped by these experiments, and they will get a very good idea of uh, how to go about these topics. So that's about what I wanted to tell regarding this advanced remote sensing and GIS lab. So now let's look into one of the experiments in mechanical engineering. Okay, so even in mechanical engineering, there are various labs that have been developed. So we have mechanics and robotics lab. Uh, Here there are some of the newer concepts that have been inculcated, that is acoustics lab is provided, and you also have 3D printing and virtual simulation lab. So these are some of the newer concepts that have been there. So let's look into one of the easier topics. So that is engineering graphics. So here we have, again, we have a total of 10 experiments. So this is a drawing subject. So let's see. Here, if we take projection of planes, for example. So now I'll be directly moving on to the simulation part, because again, in the theory, we have what is the projection of plane and what is the theory base of these planes. Next, we have some of the pre-test and post-test questions regarding the plane topic itself. And again, in the procedures tab, we have a detailed explanation of how each and every step is to be done. Okay, so let's see how we'll be doing this in the experiment. Okay, so now let's, and then in the references tab, we have the references and the contributors list. So now we'll move on to the simulation. So now, what is our objective? The objective is to draw the projections of a pentagon of 25 mm of side, having the surface inclined at 30 degrees to horizontal plane and the side parallel to HP, and the incline at an angle of 60 degrees for the vertical plane. So these are the three main values that we have to remember in order to conduct the experiment. That is, the side of the regular pentagon has to be 25 mm, and the degrees, surface inclination to HP is 30 degrees and to VP is 60 degrees. So that is the main objective. So these are the apparatus that we'll be using. And now we will be moving on to how we will be conducting this experiment. So now the type of projection discussed here is related to the planes. So we have to answer this, and we'll be drawing our axis. So here is our XY axis. So now, after we have drawn the axis, we have also we have to answer these questions in order to move forward. So what is the correct way to abbreviate drawing on a grid sheet? It's DRG. So now we will be naming what is HP and VP. So this is the vertical plane, and at the bottom we will be providing the horizontal plane. So now we'll move on to the next step. So what are the number of edges on a pentagon? Has 5 pentagon, 5 sides. So we have drawn the pentagon on our horizontal plane. So number of vertices. So the number of vertices are also 5. So we will be naming the vertices as A, B, C, D, E. So that is done. So now we are dealing with the projection of pentagon of sides. What? So this was in the question itself, that is of 25 mm. So we will be projecting the lines. So now we have to choose the correct projection points. So now here at the XY line, we have to name the projection. So what will it be? E dash, A dash, D dash, B dash, C dash. So where is that? Yeah, that's the second option. So we will be drawing this. So now once this is done, we will be moving on to the next step. So again, what is the inclination angle to HP? So this was given in the question as 30 degrees. So we'll be plotting the inclined line, and on the inclined line, we will be placing this E dash, A dash, D dash, B dash, C dash. Okay. So now what is the color of the projection line? So here we can see the solid lines are in black and the projection lines are in gray. So just click on the right option. And now we'll be projecting whatever is there on this VP inclined line to the horizontal plane. So now we have brought it back to the horizontal plane. So now we'll move on to the next step. So what is the inclination of angle to VP? So that's 60 degrees, which was given in the question. So we'll be plotting the side, and then we will be transferring these points to this inclined line. And the next step, what are we doing? The top view of the is, so this is the top view, correct? So the top view will be on the horizontal plane. So we will be projecting this plane up and bringing it here. So here is the front view. So if a 25 mm side of pentagon is inclined at 30 degrees to the horizontal plane and 60 degrees to the vertical plane, this will be the front view and the top view that will be getting from this particular question. So the students can also get a very good idea of how they have to move forward in drawing these projections. So that's about one of the experiments in mechanical engineering. Okay. So now, along with uh, this website, I'd like to introduce you to another website, that's RT Labs. So I think in the introductory sessions, this was introduced to you. Yes. So RT Labs is nothing but remote triggered labs. So in this, I'll be taking you to the virtual tour of one of the labs in NITK. So directly we'll go to virtual tour. So here we can see strength of materials lab or fluid mechanics lab or the vibration lab. So let's look into strength of materials lab. So here uh, is the lab that is there in NITK. So here when we scroll down, also we can see we can directly move on to the different experimental setup directly. So this is the UTM machine. Okay. Then we can go on to the direct shear test and bending test machine. So this is the experimental setup that we had used for conduction of our direct shear test experiment. And then we have the various impact test machines as well. So along with this, you can also look around the laboratory. In this manner. Okay, so we can also directly go on to the different machines as well. So here again we have a high resolution image of this experimental setup. So again, even in the impact testing also we have different options of how this particular setup has to be conducted. Sorry, how this particular experiment has to be conducted. And with this we have the instrument setup as well. So similarly, you can move around and have a look at the various experimental setups. So again, we can look into the fluid mechanics lab as well. complete slide. So here you can see the, okay, so here we have a irrigation model. So you can directly move on to Francis turbine. Then we can look into the experimental setup in great detail. Also, we have impact of jet. Okay, so this is the impact of jet setup. Yes. So that's about this V-tour as well. So if anybody wants to look into the experimental setup of different experiments, they can come and have a look here. So that's about the virtual tour. So along with that, we have something called as RT labs. So RT labs is nothing but remote triggered labs. So what you had already seen in the virtual labs website is the simulation. That is, there is no physical lab present. It is completely coded into the website, and any student or person with a stable internet connection can do this experiment. But in RT labs, what happens is there is a physical lab that has been set up for this purpose, and the student or the learner can connect to this laboratory via a server and conduct the experiments and download real-time data. So let's first see how this lab is. So one of the labs that has been developed is the vibration lab for mechanical engineering students. So here you can see the various experimental setups. So this is the fixed beam and cantilever beam vibration. Also, we have the free pendulum experiment as well. So this is the servers through which this will be working up. So let's go to RT Labs, Vibration Lab. Let's see if I will be able to connect. Okay. So here the user interface is slightly different. So we at the top we have the uh, navigation bar. So through this you have, but the concepts are almost the same. So here we have the information regarding the theory of reconfigurable simple pendulum. And next we have the procedure of how you will be having to conduct this particular experiment. Okay, so this is how your web page will be looking like once you start the experiment. Okay, so you will be getting real-time data based on the triggering that you have done, and you can download these data results. And again, in self-evaluation, you'll be having some of the important questions. Okay, so in the virtual labs, simulation labs, you had something called as simulator, where you had to do the simulation. But now here you have something called as remote trigger. So as I'm inside NITK, I'll be using the NITK network. And let's see if I'll be able to connect. So there was some maintenance work that was going on. So basically what happens is we will be connecting to this particular experiment, and we'll also be able to live stream. So then we will be getting a time frame of 5 minutes. So we will be connected to this particular experiment for 5 minutes, and we'll be given the option to trigger this particular experiment for 3 times. So along with that, I'll be able to change the length of this pendulum as well, and see what is the difference in the amplitude that we will be getting. So, okay. So I request you to look into this particular website at a later stage so that you can show the students the this particular experiment. So the major advantage of RT labs is the student or the learner does not need to be present physically in the lab. but there will be a physical lab developed for the sole purpose of conducting the experiments remotely. So that is why it is called remote trigger labs. So that's about the RT lab function. So again, moving back, we have about 10 to 15 minutes remaining. So let's look into any one of the experiments. Okay, so let's look into one of the experiments in remote sensing and JS lab, as this is, I think most of the participants will find it interesting as it's completely new and not usually available for regular engineering students. So yeah, let's do extraction of topographical features using DEM data. Okay, so here also we have some theory portion. So DEM is nothing but a digital elevation model. That is a digital representation of the surface characteristics. That is the elevation, terrain, what is the slope, so all those things. So here in this particular digital elevation model, we have a change in elevation from 0 to 2,685 meters. Yes. So the DTM is so in them again we have two types, that is DTM and DSM. So DTM is nothing but it provides the features of the only the ground. But DSM, that is digital surface model, also provides any extra things that are present on the ground. So that if a car is there, then that one's height is also considered. If a tree is there or if buildings are there. So in the digital surface model, all these data points will be available, but in the digital terrain model, only the ground features will be provided. So that is about DTM and DSM in the theory portion. So again, we have something as pretest, post-test. So that's the same things. And then in the reference section, you'll be having different reference material. In future, as this is a very new lab that has been introduced to VLab, the simulation demo and the experimental demo videos are yet to be up. So, but they will be uploaded very soon. So let's move on to the simulation. Okay, so now here the objective is to extract the topographical features and delineate watershed from the shuttle radar topographic mission. So that is the SRTM data. So SRTM is nothing but a satellite that is providing this particular data. So there are different satellite ranges as well. So you have SRTM, we have Landsat, we have different kinds of Landsat satellite data as well. So now here we'll be finding out different topographical features. So let's move forward. So let's first choose the map. Okay. Oh, so now I have selected the Bangalore map. So now we have color ramp. So let's choose this. Okay. So we'll click on the image to proceed. So now we'll take this as classified, or you can take it as stretched. So these are the different symbology types. So how you want to actually showcase your map. So next we have elevation, we have slope, we have hillshed. So now we'll be doing the watershed delineation. So we will be using the elevation data. So this is the aspect. So now coming to watershed delineation, we'll be using. Okay. So there is something called a stream network. Okay, so now let's do flow direction. So this is the direction of the flow. We can also put in the legend, excess flow accumulation. Next is the stream network. So in the stream network, we can tell what is the stream networks is the points joining the lowest elevation. So where our major river streams will be present. And next we have the watershed. So for Mangalore region, we have two basins. Okay, so this is basin 2 is a major basin, and next we have a basin 1, which is a smaller one based on the elevation of the particular area. So that is about extraction of topographical features from them data. Back. Okay, so here we have something like, okay, we can look into photogrammetry survey as well. So we'll directly move on to simulation. So here first we have to unfold the antennas of our controller. So how many rotors are present in an octocopter? That's 8. So in a quadcopter, all the motors are in the same direction. That's false. So now we will be connecting the remote controller and our tab. So this is the drone setup, and we will be placing the propellers. So 4 propellers onto the quadcopter, and we'll be placing the battery inside this. So we have to unfold our landing pad, place our drone onto the landing pad, and make the instrument ready. So now next is to create a flight plan and start the mission. So we will be flying, and flying height, you can choose the flying height. Okay, so this is the total area that the survey will be conducted. So drone is set up, transmitter is set up, we have placed the landing pad, and we have also done the iPad work. So now we'll be starting the mission. So now the drone will be flying onto this exact path. To gain the photos. So a total of 59 acres will be surveyed within a time of 15 minutes. Okay. So now once this is done, the drone will come back to our home position, and then after this we'll have to take out and upload. So now we'll be uploading our images. So here is the orthomosaic map of this particular area. We also have the digital terrain model, and here it ranges from 6 meters to 12 meters. So it is a relatively flat ground. So now we have the digital surface model as well. So I think you'll be able to understand what is the difference between digital terrain model and digital surface model. So in the digital terrain model, you can see the difference is from 6 meters to 27 meters. Okay, and the height of the trees, the buildings, if there is any bund or some farming is going on, all those portions you can see in a digital surface model, whereas those points are not very much clear in a digital terrain model. So in a digital terrain model, major uh, uh, ground features only will be provided, but in a surface model, all your uh, buildings, tree heights, all have been considered. Okay, so these are the observations. So depending on the flight height, the resolution of the orthomosaic map will be changing based on the GST, that is ground sampling distance. And as the flight height increases, we can see our flight time decreases. Okay, so that's about this photogrammetry survey that we have to that we conduct. Okay, so here there is also something called as front overlap and side overlap. So this is nothing but the amount of overlap that two successive images have during the image capture. So if the front overlap and side overlap are less, then the stitching of the images will not be of great quality. So in order to get very good quality of images, we should have minimum of 60 and 40 is the minimum requirement, but in practical conditions, we'll be providing minimum of 70% side and 70% front overlap. So that's about one of the experiments in GIS lab. So that's all from my side for today. Let me stop sharing my screen. Now, if you have any queries or doubts regarding the session that has been handled, you're please free to ask right now.
Dear participants, if you have any questions, you can please post in the chat box. Yes, ma'am, we have a question from Mr. Vijendra Singh Chaudhary. Says, can you explain the experiment on refrigeration, air conditioning in mechanical engineering?
Okay, I'll look into it because I am from a civil background. I'll see if any of the mentor from mechanical will be able to join. Just give me a minute, okay?
Sure, ma'am.
Yeah.
Thank you.
Thank you. Meanwhile,
the
if
others
there are
also
any other, yeah, if there are any other questions.
Ma'am, some of the participants are also asking for the expression of interest form. If you can post it in the chat box.
Yes, sir. I'll talk to my colleague right now and I'll look into what can be done. Just give me a minute.
Yes, yes. Thank you. Meanwhile, as you post your questions in the chat box, dear participants, the feedback link has been posted for today. It's posted in the chat box. I request you all to fill the feedback form.
Sir, Shrestha is trying to she's trying to post something. So I'd request you to please make her as a co-host.
Okay, ma'am. Okay.
Yeah. So she'll be able to place the expression of interest in form. Or
Sure,
something like
sure.
that. Yeah.
Yes.
Yeah. about high-speed jet facility experiments, I think you're talking about impact of jet. Am I right, Arun ma'am? Or sir? Yeah, so that's available. If you want, I can show that experiment. Just a minute. Share my screen. So yes, going back to the civil engineering, and I think it's in fluid mechanics itself. Directly move on to the list of experiments, and we have impact of jet. So in this experiment, we can do this thing. So here we have three options, that is for flat vane, hemispherical vane, and inclined vane. Okay, so let's take anyone and let's move forward. So now we'll move the counterbalance weight to make the arm horizontal. Okay, so we'll be looking into the bubble and we'll be making the arm horizontal. So then after this, once the balance is made, the length and weight of the counterbalance distance are measured using a scale. So now we have to measure what is the A distance and the D distance. And from that, we'll be placing our weights. And then we'll allow the water to flow in. Again, we'll be making our arm horizontal. Move on to the next step. So now this jet is being directly applied to a flat vane, and now we will be looking at the what is the final discharge and the time taken for 5 centimeter height of water to be filled. So again the same thing, area into height divided by time taken. So area is 3600 into our height was 5 centimeters divided by the time, that is 43.8. So that comes out to be 410.96. Let's check it. Yes, that's right. So now we can find out what is the velocity of the jet, that is Q by A. So here, these are all the observations. So now I'll add an arbitrary value. And then again, we have what is, we can find out the theoretical force, that's FTH. So all the data that you'll be needing for substitution of these values are either already calculated or present in the observations part. So here we need what is density and what is the area and what is the velocity. Okay. So again, let's check it. Again, we have what is the actual force, F actual. So again, sorry. Again, we have what is the weight of the pan, and we had found out what is A and B, distances A and B. So it is 25 into B, that is 63, divided by 14.5. So that is 11667. Did some mistake there? Okay. And we can find out what is coefficient of impact by F actual by F theoretical. So that is 1.1445 divided by 1.26. So that comes out to be 0.84. Yes. So similarly, we have trial 2 and trial 3 for the, but the procedure is completely same. I think that's sufficient. Okay, any other queries? I think the expression of interest form has been shared. Yeah, you're welcome. So all the experiments, I can talk very confidently regarding the civil experiments. All of them are quite clear, and most of the experiments are based on the physical experimentation itself. So you will be getting a very good idea of how the experimental setup is and what are the different stages of conducting the experiment. So I think students will be greatly helped with the introduction of these experiments to them. And I request all the faculty members as well to explore. And yes, it's not that it's completely correct right now. We are constantly working towards making this much more better for the students. So your feedback is also very well appreciated. So are there any other queries regarding today's session?
Dear participants, if you have any queries, please post them in the chat box, or you can directly ask ma'am. She will be able to clarify your doubt. Or if you can also post your questions in the feedback link. We can share the feedback link with the team so that they can get back to you. The feedback link has been posted in the chat box. I request all the participants to please fill the form. This will be considered as your attendance for today.
Yeah, so we have few queries like regarding mechanical. So to add on to what Ashika told, in case if you need on particular demonstrations, specific demonstrations, if possible, if we can accommodate tomorrow sometime with at least 1 or 2 examples, then we'll try to accommodate it in tomorrow's segment.
I think if there are no more questions, we can call it today and we can close the session for today. Thank you once again, Vaishali ma'am and Ashika Pai ma'am and Shrestha ma'am for today's session. Dear participants, thank you once again for joining for the day 4 of the 1 week online FDP. Tomorrow is the final day of our FDP. And till now, we've been looking at the demonstrations of various of virtual labs of various disciplines. And tomorrow we'll be looking at how we can actually create one. Okay, so we'll be looking at the brief overview of creating virtual labs, how we can actually create a virtual lab for maybe a particular discipline or particular experiment. Or we'll be looking at that. And also we'll be looking into an exciting part, which is the immersive experiential learning through virtual reality. So how we can actually have an immersive experiential learning through virtual reality. We will be looking into those 2 sessions tomorrow. So tomorrow it will be the same time. 10:30 will be our starting of the session, and for 10:30 to 12:30 will be a session, and followed by inaugurals. Since tomorrow is the last day, tomorrow we will be having a valedictory. A valedictory of the program tomorrow afternoon. So I request all of you all to be there, to be present for the valedictory, and tomorrow we'll be also having the overall feedback for the whole 5-day sessions. So I request all the participants to be there, and this will be important for your certificate as well. So thank you everybody for joining us today. As ma'am said, maybe tomorrow afternoon we can accommodate a session for specific experiments if you want any kind of demonstration or so. So maybe you can post it in the feedback link, or you can post it in the chat box right now as we speak, so that we will have an idea of what experiments to be shared or to be explained in detail, so that we can have a session tomorrow afternoon, right after the validatory program. So please keep that in mind. Once again, thank you, dear participants, for joining today. Thank you, the NIT team. Thank you for today's session.
Thank you, sir.
Thank you, ma'am. Thank you. Thank you, everybody. Have a great day. I'll see you all tomorrow.